in example number 4, we have another one to get comfortable with. We want to solve and graph the inequality I have here. 3x minus 8 greater than or equals 7. Alright, and in this one, once again, my inequality here start out being in the second form of the ordinary form, so I don't have to worry about I don't need to do any longer, I no longer need to try to bring it into the ordinary form. It's already in ordinary form. So what I have here is notice the inequality points to the right side, so I need to produce two separate inequalities. One of them is the 3x minus 8, just the exact expression inside the absolute value sign. I'm putting it greater than or equal to 7. The other one is I'm doing it the same, 3x minus 8, but I put it less than or equals 2, and then with a negative 7 this time. And here I connect the two inequalities by the OR. And so now, once again, we have spent a lot of time learning how to solve these compound inequalities with the OR keywords. So just think about you solving these two independently. We have 3x greater than or equals to 15, and dividing both sides by 3. That gets me x greater than or equals to 5, and the other one here. Or, the other one here, when you're adding 8 to both sides, what's going to happen here? 3x less than or equals to 1, and dividing both sides by 3. That gives me x less than or equals to 1/3. Okay? So, that's how you logically found the answer to the two solutions. You found the answers, you logically found the solution to that inequality. Now, to graph the inequality here, once again, x greater than 5, you can think about separately. That's the line, on the line number 5 is right here. Okay, greater than 5 is that, and greater than or equals to 5, I'm using brackets on 5. Okay, and then think about another line, negative, 1/3 is somewhere here. X less than 1/3, so I'm shading to the left, less than or equals to 1/3, so I'm using brackets on 1/3. So now, combining the two solutions together with the OR, what I have here is going to be, so here's 1/3, here's 5. So what I have here is just wherever the two regions reach, wherever the two shading reach, that's the overall graphing of your inequality solution. So this is the final graphing of your inequality solutions. And then the last one, and bringing that into interval notations, what you can do is x greater than or equals to 5, so I have within that interval right there, we have 5 comma infinity. And for the other one, we have negative infinity, comma 1/3 with brackets there. And now we union the two inequalities together. And that's how we get that. Let's look at example 5 here. And once again, we want to solve and graph. And the inequality that we have is 3x minus 1 plus 2, all of that in absolute value, less than or equals to 20. And once again, you can see that as we move on further into the examples, you can see that the inequality, the absolute value expression is growing larger and larger. However, still, the good thing is this inequality in the end, overall, it's still in the ordinary form, in one of the ordinary form. For the reason being, even though we have a very large expression right here, but then all of that is, we only have one absolute value. It's not like a 2 or a 3 in front right here. There's just leading coefficient 1. There's just the coefficient 1 multiplied with that whole absolute value. And so, and the inequality right here is pointing to the left-hand side, so I can see that we're in form 1, we're in the ordinary form number 1. So I can just simply do 3 times x minus 1 plus 2, less than or equal to 20, greater than or equal to negative 20. Okay, and once again, the discussion in class explains why we are doing all this. And now, for this final compound inequality right here, just simply subtract 2 from both sides. Okay, and that gets me 3 times x minus 1 less than or equals to 18 and minus 22, or minus 22. And then you can also do, now, you need to multiply the 3 through each term in the middle side. So we have 3x minus 3. That's 18. And so I can also add a 3 to our side. Okay, and that gives me 3x less than or equals to 21 and greater than or equals to, here it's just 19. And so finally, to come up with the solutions, dividing both sides by 3. That gets me x less than or equals to 7, greater than or equals to 19 over 3. And so that is my logical solutions here. And then graphing the solutions. Once again, here's my lower end, here's my upper end. The inequalities both contain the equal signs. So that gives me some expectation about using brackets waiting for me ahead. So 19 over 3 is on one end, 7 on the other end. Okay? And now x is greater than or equals to the lower end and less than or equals to the upper end. So I need to shade in between the two ends. And then brackets on the two ends right here, just because the two inequalities include the equal signs. And now, as an interval notations, I have 19 over 3 comma 7. And brackets on the two sides. That's my final solutions in interval notation. Example number 6. We would like to solve and graph again. What I have here is my inequality. I have 3x minus 3 over 9 greater than or equals to 1. Still, even though the expressions with the absolute value sign is growing much bigger, and what's worse here is that it's involving some fractions here. However, the good thing is that we still only have just one absolute value sign. There's no 2, there's no 3, there's no 5, there's just one absolute value, greater than or equals to 1. So what I can see here now is I can just simply, and here's a spawn 2. So the inequality is pointing to the right-hand side. So I can just simply do 3x minus 3 over 9. I just simply copy down that expression trapped inside the absolute value sign. Now without the absolute value sign, that expression is greater than or equals to 1. Or that same expression, 3x minus 3 over 9 is less than or equals to negative 1. So hopefully, after some good number of examples here, you're going to start recognizing a pattern of how you can solve these problems and get yourself locked into that pattern of work with that. And so, solving each inequality here independently, multiplying both sides by 9, you can have 3x minus 3, I meant the 3, greater than or equals to 9. Or, the other one, 3x minus 3 is less than or equals to negative 9. And so adding a 3 to both sides, that gets me 3x greater than or equals to 12. And adding a 3x less than or equals to negative 6. And dividing both sides by 3. And I can just divide without worrying about sign change, inequality change. So that gives me one x value is greater than or equals to 4, and the other 4. The other value here is x less than or equals to negative 2. Right? So here's my logical solution with the inequality. So now graphing my inequality, and this time, hopefully throughout so many examples, trying to graph, and hopefully you've been getting comfortable with using more than one graph to bring them together. So now I'm gonna make it easy. I'm gonna keep it simple for me, save myself some writing. So I'm gonna just start out with the very final one. So I have 4 and negative 2. And if you still want to stick with the traditional way of using the 2 separate lines and bringing them together, that's still fine. But here, since we have spent a lot of time working with those, I hope you already get comfortable. But here, I want x greater than or equals to 4, so I'm shading to the right side of 4, and I'm using brackets for that. And also, x is less than or equals to negative 2. So that's my graphing of the inequality. And so once again, it's all because, once again, one part is we count all those x values higher than 4 or equals 4. And we also, or those x values less than or equals to negative 2, we count them too. So that's why this graph right here, the domain, the shaded domain is actually the 2 areas right there that we're shading. So the final, the interval notation for this final solution here is going to be, the first portion over here is 4 comma infinity, and the next one is negative infinity comma negative 2. And we join these by the union sign, because remember, the or here means a union. Example number 7. This time, once again, still solving for a graph. Solve and graph the solutions. But let's say we now going to allow the inequality to grow out of ordinary a little bit. So it is now obvious that my inequality is completely out of ordinary. It's none of the form. Now, the absolute value expression here comes with a 3 in front, meaning it's 3 times absolute value expression. So that's not what we want. We want just the absolute value sign only, the absolute value expression only with coefficient 1. So we need to divide the 3 away eventually. And then there's a 2 added to that absolute value expression. So we need to rearrange that 2 to the other side. So trying to bring all this inequality here back to the ordinary form, back to one of the ordinary forms. What I need to do is subtract 2 from both sides, and that gets me 3 absolute value of x minus 1 greater than or equals to 6. And now I can simply divide both sides by 3. And that gets me 1 absolute value sign of the whole x minus 1 greater than or equals 2. And here I ended up my inequality in the ordinary form, in one of the ordinary form. And in this form here, you can see that the inequality is pointing to the right hand side. So here I need to do, according to the guideline, I need to produce for myself 2 separate inequalities. X minus 1 greater than or equals to 2, and or the other one is x minus 1 less than or equals to negative 2. And here solving for that, think about these 2 independent ones. Adding 1 to both sides. X greater than 3, adding 1, x less than or equals to negative 1, and here's the or. So, graphing the solutions. 3 is the higher number, negative 1 is the lower number. For 3, I want x higher than 3. So, in this, the solution for this starting inequality here is, as long as x higher than or equal to 3, or x less than or equals to negative 1, that counts for the inequality. So I'm using brackets on the 2 answer here. And so that's how I can graph it. And the interval here is going to be 3 comma positive infinity, and negative infinity comma negative 1. That's how we get it done for example number 7.